Alright, we're going to talk about a second algebraic method for solving systems of equations. This one is called the elimination method. The big idea behind this is if you can eliminate one of the two variables, then you can solve for the other one. Now, the way that we're going to eliminate a variable is going to deal with the addition principle of equality. You guys know that you can add the same amount to both sides of an equation, and the equation is still true and the solutions still hold. Okay? You can also subtract the same amount from both sides, multiply the same amount to both sides, divide the same amount from both sides, etc. And so what we're going to do is we're going to utilize the addition one. Now what I'm going to do in this example is I'm going to add the same amount to both sides of the first equation. So consider this first equation, the top one. What I'm going to do is I'm going to add a -8 to both sides of the equation. Obviously there's a -8 below the right side, but this stuff on the left side, 2x minus 3y, is equal to -8, and so essentially I'm adding -8 on the right and -8 on the left, because the stuff on the left is equal to -8. They're the same. So if I add the -8 to the 5 and add all this stuff to the terms above, then I'm essentially adding -8 to both sides of this equation. Okay? So here's a -8, that's one copy, and here's the other -8. That whole thing is equal to -8. So essentially I'm adding -8 to both sides of the first equation. Now when I do that, you think about it that way. Alright, you add down x and 2x. You're essentially adding like terms. You get 3x. 3y minus 3y, well, those drop out. They add up to 0y. And on the other side you have 5 minus 8, or 5 plus -8, which gives you a -3. Now the 0y is really unnecessary. I just wrote it down there to show you what happens to the coefficients. But really all we have is 3x equal to the -3. And of course if you divide out the 3, you're going to get -1 for the x value. Now we've said before that just one value does not solve the system. You need both the x and the y. So here I'm going to need to solve for the y. I'm going to put this x back into the first equation in order to solve that, because the numbers are a little bit smaller there. So I'm going to take the x value plus 3y equal to 5, and of course the x value there is the -1 that we talked about a moment ago. We're going to solve this equation, of course, just add a 1 to both sides. These will drop out. 3y will equal, what's that, 6? Divide by 3, and you'll be left with a 2. And so the final answer must be the ordered pair -1, 2. Again, in solution set notation. Alright, so again, the big idea there is you add the same amount to both sides. Essentially you're just combining terms and adding straight down the columns, but it's equivalent to the addition principle of equality. Once you do that, one of the variables is eliminated, right? It's the elimination method, so you eliminate a variable and solve for the other variable. Okay. Just as a quick check, if you plug in -1 and 2 into this original equation, -1 plus 3 times 2, well, 3 times 2 is 6. -1 and 6 will make 5. And if you plug them into the second equation here, 2 times -1 is -2. -3 times 2 is -6. -2 and -6 makes a -8. And so that does check out. This is definitely a solution. Okay. We'll do a second one. This one is going to be a little bit different. Let's separate this off. Alright. This one, we're going to go with 3x minus 2y equals 0 and 5x plus 10y equals 4. Now if I proceeded like I did on the last example, there's a slight problem. I can't just add the equations together and eliminate a variable because none of the variables drop out. Right? If I add these up I get 8, add these up I also get 8. I don't get any zeros. And so what I need to do is get opposite coefficients. Notice in order to get the 0 in the last equation I had to have opposite coefficients, a positive 3 and a negative 3. Well, I need opposites here as well. And so I'm going to utilize the multiplication principle of equality to do that. I already have a negative and a positive on the y, so that might be the easiest one to work with. In order to get these to be opposites, I need to build the 2 up to a 10, or find the least common multiple, get them both to the same thing. So to do that, I need to multiply this negative 2 by a 5. But I can't just multiply one part of an equation. I've got to multiply the whole thing, both sides of the equation. So I'm going to multiply it all by 5, and that distributes to every term. So 5 times 3 is 15x. 5 times negative 2 is negative 10y. 5 times 0 is, of course, still 0. The other equation I'm going to just bring across. Doesn't change. That's 5x plus 10y equals 4. And now when I add those together, you'll find a 20x, but you'll also find that the y's drop out now. They're opposite coefficients. On the other side I get a 4. If I divide out the 20, x is going to equal 4 over 20 is 1/5. Okay, so now the 1/5, of course I need the ordered pair, so I plug that back in. Now if I put 1/5 up into this first equation, I get 3/5. I'm dealing with fractions. But if I put it into this second equation, 1/5 times 5 is 1, the fraction drops out. So I'm going to use that one. So let's go with 5 times my 1/5, which I'll put in a moment, plus 10y equals 4. The x value becomes 1/5. 5 times 1/5 is 1. Subtract the 1. 10y equals 3. Divide by 10, and you get 3/10. And so the final answer is again the x and the y value combined, 1/5, comma 3/10. Again in set form. Okay. Alright, got a couple more examples for you in the next video.